Okay, so we've got these three congruence questions here, and they're all sums. And what we need to do is to find the number that they are congruent to, modulus 5. Now they're all a little bit similar, apart from this one, of course, which is factorial. They all go from 1 to 100. This is the sums of the digits from 1 to 100 cubed, and what it's congruent to. This one is to the power of 4, and what it's congruent to. And this one is the sum of all the factorials up to 100 and what that is congruent to. So we're going to use some properties of congruence and see what happens. Okay, so 1 cubed plus 2 cubed plus 3 cubed. Now just to calculate this out, it's going to take you all day long. So we need to find some kind of shortcut. So if we just rewrite this. So n equals 1 to 100. That's all our sums. And it's basically n cubed. So we want this to be congruent with a mod 5. So how are we going to break this down? Well, we can see that these two numbers here are both coprime, so that's helpful to start with. So maybe we can break this down and see what's happening with the first few numbers. So I'm going to write here 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. Here I'm just going to write down what the answer to these first 6 is. That's 1, 8, 27, 64, 125, 216. Now here on this line I'm now going to write the congruence mod 5. So I'm going to put mod 5 here just so as we can see that's what we're trying to work out. Here I'll just put an equal sign, and here I'll put a congruent sign so you can see the line. So mod 5, 1 is just congruent with 1, that's easy enough. 8 is 3. 27 is congruent with 2, mod 5. 64 will give us a 4. 5 will give us a 0. 216 is 1 again. Now there's going to be a pattern forming here by the looks of things, but if I just write in this one here, 7 cubed, I can estimate that it's probably going to be very similar to the 2 cubed in terms of the congruence. In fact, it's going to be exactly the same, I would say. So 7 cubed is 343, which is then going to give us a 3 in terms of the congruence. Okay, so we need to rewrite this a little bit to try and fit in with what we're trying to do here. So we're using the digits 1, 2, 3, 4 and 5, and then the sequence 6, 7, 8, 9, 10 is going to be the same as 1 to 5. So now what we want to try and do is rewrite this to fit that. So if n equals 0, and then if we're doing groups of 5 all the way up to 100, there's going to be 20 groups. If we're starting from 0, our sum will go to 19. And then what we can do then is write 1 plus 5n. So when n is 0, we've got 1 in this box. When n is 2, we've got 11 in the box. When n is 1, we've got 6 in the box. And then we write that number cubed. And then with the original question, we're adding. So now we're going to add 2 plus 5n cubed plus 3 plus 5n cubed. I'll just continue down here. Plus 4 plus 5n cubed. And then 5 plus 5n cubed. Okay, and then we'll say that this is congruent with our number A, mod 5. But first of all, let's just work out what's going on in here. So in terms of congruences, we can write these digits in place of these. So now what we'll say is n equals 0 to 19. 1 plus 5n cubed, that's going to give us a 1. So if I just put this in a bracket, that's going to give us a 3 for the 2 plus 5n. For the 3, we need a 2. 4 plus 5n is going to give us a 4. And 5 plus 5n cubed, well, mod 5 is going to give us a 0, but I'll write it in anyway so we can see what's going on. And that's congruent with a mod 5. Okay, the mod 5 I won't write in, we know what's going on now. So now we can just add this up. So that's 1, 4, 6, 10. So that's going to give us 10. Okay, so our total here is 10. And then if we just go through the process of just adding them all up, we've got 20 lots of these. So 20 times 10 is a 200. So then what we can say is that 200 is congruent with a mod 5. So of course our a here is going to be 0. So a equals 0. And then just to give us every solution, we can say a plus 5n. Okay, so that's the first one. Okay, so now we've got a very similar one to the first question, except this time we've got to the power of 4. Now mod 5 to the power of 4, we can use here a version of Fermat's little theory. So here we got a to the n minus 1 is congruent with 1 mod n. So that's a version of the Fermat's little theorem. Now here we can see if our n is 5, we've got n minus 1 in all the powers. So let's just have a look what's going on here. So if you look at the first 5, just as we did here, we've got 1 to the power of 4 is going to be congruent with 1 mod 5. Obviously 1 to the power of 4 is 1. 2 to the power of 4, that is going to be congruent with 1 mod 5, just by this theorem. Now 2 to the power of 4 we know is 16, so I'm just going to write that here so you can see. 3 to the power of 4 the same. This is going to be congruent with 1 mod 5. 3 to the power of 4 we know is 81. So you can see the pattern is forming here. 4 to the power of 4, that by the theorem is going to be also congruent with 1. 4 to the 4 is 256. So if you check that, mod 5, yeah, we can see that. So now we're going to write 5 to the power of 4. Now here, we can't use the version of Fermat's little theorem. This 5 and the mod 5, these are not coprime. So this version here does not work. But 5 to the power of any number, let's just write that here, 5 to the power of n is congruent with 0 mod 5. So basically, if I just write this as a k to the power of n is congruent with 0 mod k. So for any k, it's always going to be 0. So this one here is going to be 0 mod 5. Okay, so now just writing these in the sum format here, like we've got, I'm going to write n equals 0 to 19. And I'm just going to go straight into the congruences here. 1 plus 1 plus 1 plus 1. Okay, we know that is 4. I'll put the 0 in there just so as we can see it. Let me just work that one out. Okay, so then if we just sum these all up, we're just going to get 4, total numbers of 4 is congruent with b. So summing all these up from 0 to 19, we've got 20 of those. 20 times 4 is 80. So 80 is congruent with b mod 5. So in this case, our b is also 0 mod 5. And just to give us all our solutions as we did here, b plus 5k is congruent with 0 mod 5. So b could be any of those numbers. Okay, so now the factorial ones. Now this one here, we can write this one up as we did here. Actually do it like this one here first. Let's just write that as a big sum first. N equals 1 to 100 n factorial. Now we can break this down a little bit because we know that this 100 factorial, that's going to end in 0, because you multiply anything by 100 mod 5, it's going to be congruent with 0. So let's have a look at the first few numbers and see what we get. So let's just go along here. 1 factorial equals 1, which is congruent with 1 mod 5. That's easy enough. 2 factorial is 2, it's congruent with 2 mod 5. 3 factorial is 6, which is congruent with 1 mod 5. 4 factorial equals 24, which is congruent with 4 mod 5. Now we're going to be multiplying by numbers 5, 6, 7, 8 and 9. So if I put the first one in, 5 factorial, that's 120. That's congruent with 0 mod 5. Now any number, whole number we multiply this 120 by, it's going to be congruent with 0 mod 5. So the last 95 numbers on here we can sort of discount. So all we need to do now is just add up these first few, and that's going to lead us to our answer. So if we just go from n equals 1 to 4 of n factorial, that is congruent with 1 plus 2 plus 1 plus 4, so that's 4, 6, 7, 8, which is congruent with 3 mod 5. So therefore we can say here that our C value equals 3. And just to give us all our answers again, we can put 3 plus 5k. So that's all of our answers here. And then A plus 5k mod 5. Okay.